Here we have a problem on integration. That is, we have to evaluate this indefinite integral. Okay, so we can evaluate this indefinite integral using u substitution. That is, I'm going to substitute a new variable u for the complete stuff we have in denominator over here. So let me start with u substitution. That is, let u equals to x positive 3 the whole square positive 36, the expression we have in the denominator of the integrand. Okay, since I have substituted a new variable u over here for this stuff in integrand, we have to get this complete integral in terms of the new variable u. When I get the complete integration in terms of the new variable u, at the place of dx, I must have du, so that I'll be able to do integration with respect to u. Since we have the original integration with respect to the variable x, now what I'm going to do is I'm going to find derivative on both sides with respect to x. So when I find derivative on both sides with respect to x, here I'll be getting du over dx, so that I'll be able to get du instead of dx over here. Okay, now let me find derivative on both sides of this equation with respect to x. When I find derivative of this u with respect to x, I'm getting du over dx. Now when I find derivative of this one, first I have to find derivative for the exponent over here using the power law of derivative. That is, we have to bring this exponent 2 in front of it and subtract 1 from the exponent. Then I'm getting 2 times x positive 3 raised to the power of 2 negative 1. I got the exponent in front of it and subtracted 1 from the exponent. So far I have completed derivative only for the exponent. By chain rule, I have to do further derivative for the base x positive 3. When I find derivative of this x positive 3 with respect to x, I'm just getting 1, because the derivative of this x with respect to x is just 1. The derivative of this constant 3 is 0. Positive. The derivative of this constant 36 is 0. Now we have du over dx equals to 2 times x positive 3 raised to the power of 2 negative 1 is just 1. Whenever the exponent is 1, we don't have to mention, and when this stuff is multiplied by 1, we'll be getting the same thing. So here the simplification of this one is 2 times x positive 3. Okay, now I multiply both sides by dx, so let me do it. When I do so, this dx will cancel. I'm getting du equals to 2 times x positive 3 times dx. Now I divide both sides by 2. When I do so, this 2 will cancel out. On the left side, du over 2 can be written as 1 over 2 times du equals to x positive 3 times dx. Okay, so when I have this stuff x positive 3 times dx, instead of that I can write 1 over 2 times du. So here we have x negative 6 times dx, but here we have x positive 3 times dx. So if I want to use this stuff 1 over 2 times du, I must need this stuff x positive 3 times dx over here. What do we have to do for that? So let me do some adjustments over here. So since I have to get x positive 3 over here, I just add 3 to this x, and to balance the addition of this 3, I subtract 3, and I'm taking this negative 6 as it is. Now let me write the denominator as it is, that is x positive 3 the whole square positive 36 times dx. So here I just write this x and negative 6 as it is. So what I did is I just added 3 to balance it. I subtracted 3. If I simplify this one, still it is equal to the original stuff x negative 6. Okay, now in my next step x positive 3, we can consider this is just one term, and when I combine this negative 3 and negative 6, I'm getting negative 9 over x positive 3 the whole square positive 36 times dx. Okay, now in numerator we have subtraction of two terms, x positive 3 and 9. And we have to consider this is just single term, and this is a common denominator for x positive 3 and this 9. Since it's a common denominator, I mean x positive 3 the whole square positive 36 is a common denominator for this x positive 3 and 9. We can take this one as denominator separately for this x positive 3 and for this 9. Then I'm getting integral x positive 3 over x positive 3 the whole square positive 36 negative 9 over x positive 3 the whole square positive 36, and the complete stuff has to be multiplied by dx. Okay, now what we can do is we can distribute this integration to this term and this term. So when I do so, I'm getting integral x positive 3 over x positive 3 the whole square positive 36 times dx, negative integral 9 over x positive 3 the whole square positive 36 times dx. Okay, now we can evaluate each integration separately. Okay, now let me continue on the next page. So we have integral, and now what I'm going to do is I'm going to write this x positive 3 along with this dx. So then I'm getting 1 in numerator over x positive 3 the whole square positive 36 times x positive 3 times dx and negative integral. Now I move this constant 9 out of this integration. So then we get 9 times integral. Since we have moved 9 out of the integral, we have 1 in numerator, x positive 3, the whole square, positive 36 times dx. Okay, now here I can do u substitution. Already I've done, that is like, so here for x positive 3 times dx, we can plug in this 1 over 2 times du. And for this complete stuff, I can plug in u. Okay, let me do it. So then I'm getting 1 over u times, for this stuff, we can plug in 1 over 2 times du. How do we have to integrate this one? So for this one, what we have to do is, again, we have to go for substitution. That is, let v equals to x positive 3, this stuff. So v equals to x positive 3. So here I have substituted a new variable v in this integration. Since I have substituted a new variable v for this x positive 3, so I have to get this complete integration in terms of the new variable v. So at the place of dx, I must be getting dv. For that, I have to find derivative on both sides of this equation with respect to x. When I find derivative of this v with respect to x, I'm getting dv over dx. Here, when I find derivative of this x with respect to x, I'm just getting 1. And the derivative of this constant 3 is 0. Now, when I multiply both sides of this equation by dx, I'm getting dv equals to dx. Okay, now let me continue over here. So negative 9 times integral 1 over. For this x positive 3, I can substitute the new variable v, then I'm getting v square positive. This 36 can be written as 6 square. And for this dx, we can write dv. Let me write over here. Now, 1 over 2 is a constant. It is multiplied by the part which contains variable. In integration, whenever a constant is multiplied by the variable part, the constant can be moved out of the integration. So when I move this constant 1 over 2 out of this integration, I'm getting 1 over 2 times integral 1 over u times du, negative 9 times integral 1 over v square positive 6 square times dv. And 1 over 2 times, we know the integration of this 1 over u with respect to u, that is ln of u and negative 9. So what is the integration for this one? There is a formula for this one. That is, let me consider integral 1 over x square positive a square times dx. Here x is a variable and a is a constant. So the formula for this one is, so 1 over a times arc tangent x over a positive c. So whenever we have an integration in this form, 1 over x square positive a square times dx, so this is the result of this integration. So we can use this formula over here to get integration of this part, because now look at the stuff over here. It's exactly in the form of 1 over x square positive a square. At the place of x, we have v. At the place of the constant a, we have 6. So in the result over here, we have to plug in 6 for a and v for x. Okay, now let me continue over here. Negative 9 times 1 over 6, because for a we have to plug in 6, because we have the constant 6 over here, times arc tangent v over 6 and positive c. Actually, we are evaluating indefinite integral, and whenever we evaluate indefinite integral, always we have to add the constant of integration. According to the instruction we have over here, we have to use c for constant of integration. So since I have done evaluation of the integration, I just added the constant of integration over here. And now let's consider the stuff, the variables u and v. So these two variables are taken by us to make the integration process easier. So now these two variables u and v have to be replaced by the original stuff. For u, we know that x positive 3, the whole square positive 36. And for v, we know that x positive 3. Let me continue. 1 over 2 times ln of, for u, we can plug in x positive 3, the whole square positive 36. Negative, we can simplify this 9 times 1 over 6. That is 3 goes into 9 3 times and 3 goes into 6 2 times. So 3 times 1 is 3. So that is, we get 3 over 2 times arc tangent. So here for this we can plug in x positive 3 over 6 positive c. Okay, let me continue over here. That is 1 over 2 times ln of. Now what we can do is we can expand the square of the binomial over here. So in algebra, there is an identity that is, let me write it over here, a positive b the whole square equals to a square positive 2ab positive b square. So whenever we have a square of a binomial in this form, so this is the expansion of the square of the binomial over here. So here this x positive 3 the whole square is exactly in this form. At the place of a we have x, at the place of b we have 3. So in this expansion we have to plug in x for a and 3 for b. In that case, let me erase the stuff over here. Okay, let me continue. So let me get the expansion of this x positive the whole square using the algebraic identity. Then I'm getting x square positive 2 times x times 3 positive 3 square positive 36 negative 3 over 2 times arc tangent x positive 3 over 6 positive c. Okay, now we have 1 over 2 times ln of x square. And when I simplify this one, 2 times x is 2x, 2x times is 6x, positive 6x, positive 9, positive 36, negative 3 over 2 times arc tangent x positive 3 over 6 positive c. So finally we get 1 over 2 times ln of, now we can combine this 9 and 36 and I'm getting x square positive 6x. When I combine this 9 and 36, I'm getting positive 45. Now let me take absolute sign for this expression. Here, why I'm taking absolute sign for this expression? Because this is being as an argument of a logarithm. Argument of a logarithm can never be a negative value. Always it has to be positive. Here, this expression contains variable. Even for some value of the variable x, this expression becomes negative. It has to be considered as positive. So that's why I'm taking absolute sign for this expression. Let me write the rest of the stuff. That is 3 over 2 times arc tangent x positive 3 over 6 positive c. So this is the result of the given indefinite integral.